Hi there once again and welcome to another Expresso mechanic tutorial. And in this one we're going to be creating what you see on the screen, which is of course a universal joint. In order to produce this, we're going to be using a combination of dynamic connectors and a small amount of Expresso in conjunction with an align to spline tag. That's what we're going to be about in this tutorial. So without further ado, let's see if we can make this happen. I'll start by bringing in a cylinder and we'll align this plus Z. Its radius we can make 3, its height 6. So I'm going quite small with this. I'm just going to hit O so that I can see the object. It only needs a single height segment and 14 rotation segments because I want this arrangement at the top here. Now its caps, we just want 2 segments for that. Fantastic. So we've got our first cylinder ready. If we just zoom out a little bit, what we can do is copy this twice. So command drag to copy, and then we can move these just along their Z axes so that they're separate like that, just by eye for now. The next thing to do, switch to our front view, so F4, and we'll select all of our cylinders, hit C to make them editable, and then switch to edge mode. What I'm going to do is select my selection tool here, my brush selection, switch off visible only for now, and on this occasion just click on each one of these with the shift key held down so that I can select all of this loop of edges on all 3 cylinders. So I've got it on all 3 and of course the rear faces as well. So we're ready to go, and now we can switch back to our front view, so F4 once again. With our scale tool, the Z, we need this locked because we don't want to scale them in the Z, but we just want to do the X and Y, so we'll just by eye bring these out to around here. That should be fine. And then we can think about where we're going next. We need to work with our first cylinder, so we'll hit O so that we can see where we are. Select polygon mode, and with our brush selection again we can switch the visible only back on and then shift select these 3 and these 3. And now we can think about extrusion. So if we hit D for extrude, 10 is going to be way too much. So let's see what we need. So let's try 1 and see if that's okay. Yeah, I mean 1 looks good. I think 1 is fine. And we need to do this 3 times. So we'll hit new transform twice. And we can see that we've got our basic shape for our first part of our universal joint. We need to repeat this process with the other 2. So let's have a look at our second cylinder. What we'll do actually is make the first one disappear so that it's not in the way. And it's basically a rinse and repeat on this. We need to select the brush selection tool, select these 3. Let's just get a little bit closer so that the axes don't get in the way. These 3, and then we can flip round to the other side and do the same thing again. These 3 and these 3 with the shift key held down. So we've got the polygons all selected, and now we can hit D for extrude once again and then say apply, new transform, new transform. Now at the moment this is actually incorrect because what we should have done was done the center 3 in a way, but we can't really do that because they're offset. So obviously we've got to rotate through 90 degrees, and we've got to do that around the rotation B. So we just put 90 in there. That puts it at the correct rotation. So that's the all-important final step. And it's pretty obvious anyway, because this has got to match up with the left part. Okay, great. So we've got the first two sorted out. Let's just make the second one disappear, and then we can worry about cylinder 2. So again, it's just a rinse and repeat. We want these three with the shift key held down. Let's get a bit closer. And these three, D for extrude, new transform, new transform. And that should give us everything that we need for our basic setup, and it does. Fantastic. So we've got it that far. The next thing to do is build the cylinders that create the connection points for all of our parts. So that's going to be our next port of call. Let's bring in a cylinder, and this time it does need to be orientated plus Y. Its radius needs to be 0.5 and a height of 5. We can leave the height segments at 4 and the rotation segments at 16. Before we move any further, we'll switch on snapping, and in our settings here, grid work plane, and we don't want grid line. We can then switch to our right hand view, so F3, and we'll start looking at positioning our first cylinder. So we'll bring this along and position it there. That's the perfect position for that, so just on this grid line here. So we've got our first piece ready to go now, technically. What we now need to do is just drop this cylinder into our first cylinder here, which is of course our first segment of our universal joint. And that's our first setup. The next thing to do is just command drag to copy this. We can drop it into cylinder 2, so into our right hand part. Switch back to our right hand view, so F3 again. Hit O so that we can check out our object, and we'll just actually zoom out a little bit first. Let's just bring this over here and then hit O so that we can see what we're doing. And we just need to line this up here, bring it across, and that's it. It's aligned. It's in the perfect position. So that's our two end sections set up. The next thing to do is just basically copy our cylinder 3. We'll just copy that twice. Pick it up, or pick up the two of them and drop them into cylinder 1. And then we can think about positioning these. Now before we do, we can orientate them plus X. So that gets them rotated correctly. And then we can think about moving them. So we'll go back into our right hand view, so F3 once again. And then we'll just drag these along until they're lined up there. And then I can just select, in fact I'll select cylinder 3. And we'll bring this one across until it lines up there. And that's great. That's everything done. That's all ready to go. Moving on from here, I'm going to command select these parametric cylinders so that they're all selected. Hit C to make them editable. And then we can just select the first two, and with connect objects and delete, make them into a single object. The same with these three here, connect and delete. And finally, these two, connect and delete. So now we have just single objects, and that's all looking very good. We can then select all of these cylinders, hold down the Option key and drop them into subdivision surfaces. And we're looking good so far. Now we need to start working with our cylinders once again. So we'll select those, or command select, I'll select them. And we can see that we've got the end loops around here selected. Now we want actually edge selection, so we need to swap over to there. We've got some edges already selected, but they're not really the ones that we need selected. So let's just start working on these. If we hit UL for loop selection, we can select the top and bottom end edge loops here, and we also want this inner loop and this loop, and we can start to work with these, we can also select this one here and just draw these tighter. And that's essentially all we need to really do there. And that's looking really nice. We need to do the same thing here. So we'll select these two edges, this inner loop and this loop. And then we'll do the same over here. So the inner loop here, just shift select that, shift select this loop, and this loop. And then hold down the period key and drag to tighten those up. And they're looking really nice now. So that's as it needs to be. And then finally we can do the same here. So this one, this one, this one, and finally this one. Period key held down and drag. Looking really nice. So we've got them that far. Now there's one last step that we need to do for the modelling of these. And we'll start by changing to point mode. And then we've got to select the correct points and just do a quick drag. So what we need to do, we just select the brush selection tool. We want our two endpoints here. Shift select to get these two here. This one and this one. This one, and let's just get a bit closer just to make sure of it. I just want to make sure I get the correct point. It's just that one that I want on the end there. That's the one. Okay, so I've got those points selected, and all I need to do is just drag these back. And I'm going to do it using the snap. Drag back to around there. That should be fine. It just gives us that roundness, which is what I'm looking for, just to finish this thing off. And that looks really nice. So the same deal on this. So if we select this one, shift select this one. Let's have a look, see where we are. The bottom two here. This one and this one. Just make sure that we've got that correct. We have. And then this one and this one. We can just drag these back to around there. And the same at the other end. So this one and this one. Let's have a quick look around the other side. Make sure I've only got those selected, which I have. And then drag these back to there. Yep, all looking really nice. I think we've got that even both ends. Yep, that looks really good. Okay, so looking really nice, and we just got to finish off our last one. So this one and this one, this one, and let's go over here just to make sure that we get it correct. Let's have a look down the bottom. This one and this one. This one and this one. I think we're correct. Yep, that looks good. Bring those back into there, and that should do fine. And that's great. So everything is modelled, and it's all looking really nice. Now the only thing we can do to finish this off is use a bevel deformer. So let's hold down Option and select Bevel Deformer, and that just finishes everything off. What we need to do is probably actually drop the cylinders above the bevel deformers and drop those in like that. And then we can look at the bevel deformers and start working with those. So I'll Command select all of our bevel deformers. Now the offset's much too big. We want about 0.2, and we want 2 subdivisions, and that finishes it. That looks really nice now. The only thing that we need to perhaps do, in fact I think I've done that slightly wrong. What I should do, I think, is just take the bevel deformer and put it above there. That's better. Put it above there. Let's have a look, see what we've got. Still not quite right. I think, so drop. That's it, drop them into them. I think I had it right the first time, actually. It's funny, the bevel deformer is a little bit finicky. You just have to do it the correct way, otherwise it doesn't quite do what you want. But now I think that's perfect. That's looking really nice. Yeah, so I'm happy with that. I've got my 3 segments all complete. Okay, the next thing to do, I'm going to start renaming these. I'm just going to call this left, mid, and right. So we've got those named, and then we can think about positioning things. Now, at the moment, what we need to do with our left subdivision surface here, this axis is not quite in the right place. So in my right hand view, F3, what I'm going to do is select my axis tool, and I'm going to move this over to here, because that's where that needs to be. And let's have a look, see where we are. We've got mid, that's fine. I'm going to leave that as it is. And the right hand one, if we wanted to, we could place this here as well. For what it is, we may just as well. We'll leave that there. Okay, fantastic. So we've got everything set up, and we can now think about positioning these in the correct spots, which is just there for that one. And for the left, we can drag this to here. And now everything is set up, and we've got a universal joint that we're ready to work with and animate. The first thing that we can think about are the dynamics. I'll hit Command D so that we can actually go into our project settings here. In our bullet tab here, and with the expert tab selected, we can look at the collision margin. That needs to be 0.1 because we've got a very small object here, or our objects are very small. So we'll set that to 0.1, and we'll set the scale to 10. The steps per frame and maximum iterations per frame, we can change these if we so wish. For the moment, we'll leave them as they are. If we need to change them, we can come back to it, but we'll leave them as they are. So that's our project dealt with for the moment. The next thing we can do is look at our left object here, and we can give this a bullet tag. We'll give it a collider body on this occasion, and we can start thinking about what we're going to do in here. Now, the inherit tag will make a compound collision shape, and we'll say off for the individual elements. It will be a static mesh. The size increment we'll say -1 for what it is. We'll just do that. And the bounce and the friction, the bounce we can leave as it is really, but the friction we'll just change that to 30. And that will just about do for what we've got for our left object here. We don't really need to go any further with that. For our mid, we will give this a rigid body tag, and again we can think about what we're going to do in here. Once again, the inherit tag will be compound collision shape. We can leave this individual elements off once again. No need to have that on. The shape will need to be a moving mesh on this occasion. And once again, we can say the size increment will be -1. We'll leave the bounce at 5. We'll set this to 30 for the friction. And that's as much as we really need to do. Now, the right side will be exactly the same with regard to its rigid body tag. So we'll simply command drag to copy this down here and drop it there. So that's our dynamics complete. If we just run, we'll see that 2 of them fall away and 1 stays there, and that's exactly what should happen. So that's fine. Everything is set up as it needs to be with regards to the dynamics. Moving on from here, we can think about dynamic connectors. So that's going to be our next port of call. In our simulate menu, let's go into bullet and we'll select connector. And we'll, for a start, make this much smaller. We'll make it something like, I don't know, 2 for the display. Just make it much smaller. Now at the moment this is a hinge, and that's fine. We can use a hinge, and we will use this with the right hand object. So that's connected that. Now we need to drop this connector into the right object, and we'll zero it out. That puts it in more or less the correct position. What I'll actually do, I think, is just move it somewhere to the middle of the object. That should be fine. Place this up here. So that's our right hand object set up, because this object is going to stay in the position that it's in now. The other two are going to be able to move, but we're going to leave this one as a static position. It won't change. Its rotation will, but its position won't. So a connector is set up for that. The next thing we can do is command drag to copy, and do that twice actually. Select the both of them and just clear this out. Now connector 1 needs to connect the left and mid objects, and it needs to be set up as a cardan. So we'll set that up as a cardan, and then we can drag our left object into here and our mid object into here. And we need to set this again in the correct place. I've got both of them selected there. Didn't need to do that. Just clear that out. Clear that out. So our first object is the one that we're interested in. Now this cardan, if we drop that into our left object and we just zero it out, it will be in the correct position. So that one is now set up. If we just get a little bit closer, we can take a look at that, and we can see that we've got one axis here and one axis here, and they're in exactly the right place. So that's perfectly good. Our connector 2, this needs to connect the mid to the right object. So once again, we'll drag our mid object into here, our right object into here, and the cardan we can drop into our right object and zero out, and that places it in the correct position. So that's all of our connectors set up and ready to go. Let's just see what happens. Well, they fall away, and that's not supposed to happen, so we've got a bit of an issue. We need to just make some checks just to make sure that everything is correct, and yep, that looks okay. And yes, it is. That's all set up as it needs to be. Okay, in the edit, I went into my basic tabs on all of the connectors, and I just unchecked enabled and checked it back on, and I found that solved that issue with everything falling away. So if we just play the timeline now, you can see that everything remains where it is, and that's what should happen. So if you get this problem with things just disappearing off the screen, check your connectors and just in the basic tab on off, and it should solve the problem, because everything, if you've done what I've done, everything is set up correctly and it should be fine. Okay, great. That sorts that little bit out, and we can move on from here. The next thing I'm going to do is bring in an arc, and in the plane here I'm going to set that to ZY. Its radius I'm going to make 10, start angle 159, and 201 for its end angle. I'll switch to my right hand view and just zoom out a little, and we'll drag this into position, and it needs to go at this point. So it needs to be at its at the right object's pivot point, and we can see the arc here. If we switch back to our 3D view, so F1, what's going to happen is that we're going to move our left piece, and we're going to move it along this arc. So we're going to be using the arc as a spline path. So we'll select our left piece and we'll give it an align to spline tag and drop the arc into the path. Now at the moment the left piece is at the end of the arc. We'll set this to 50% initially. So 50%. And we do not want tangential. We don't need that on this occasion, because we simply want this to move in the plane that it's currently in. We don't want it looking along its Z-axis. So that's great, that's all set up and it's ready to go. The next thing we need to do is bring in a null object, call it Expresso. If we it helps if we spell it correctly, Expresso, and we'll give it the Expresso tag. We've got the window open and we're ready to start doing some work. So the first thing I'm going to do is bring in a time node. As per usual, delete the time port, give it a frame port. I bet you guessed that was coming. Okay, so we've got the time there. The next step is to bring both the Align to Spline tag in and the arc. I'll bring both of those in, get these set up. So the Align to Spline, we simply need to, in our tag properties, give it a position port at the input stage, and the arc needs a rotation B port, so rotation B. So they're ready to receive their necessary data. Following on from here, we just need to grab a couple of range mappers. So we'll bring one in, command drag to copy, and we've got the two. We can connect the frame port from our time node to the input ports. And now we can think about what we're going to do with these. Well, in our top port, or our top range mapper, I should say, our input lower can be 0, and our input upper will make that 1000. And this is going to relate to the number of frames, so we'll make this 1000 in there. Okay, so that's what we're relating that to. And then 0 to 1 for the output upper and lower is fine, because we're going to be using this to control the position of our spline in order to make our left part move up and down the spline. That's what we're going to be doing. Now, in order to control this, we're going to be using the spline here. That's going to be very important. So the first thing we're going to do is command click to create our first point, and we'll twirl this open. And we want this first point along the y-axis to be 0.5. That's going to be essential. And we'll then command click to create a second point, drag this over to 1 on the x, and make this 0.5 on the y as well. So our start and end points will need to be 0.5, which will place this left-hand part exactly where it is now, 50% of the way along the spline. That's what we want. We can then command click to just put some more points in. We can put these anywhere we want, really. You know, there's no specific way to do this, but we'll put some points in and we'll just start working with the tangents. Now, our left tangent will make this 0.125, I think, if we can. Let's just undo that for a minute if I can. It's 0.125. Oh, in fact, it's minus, I beg your pardon, minus 0.125. That's better. We don't really want to break the tangents either, so we'll make them the same. And as I say, there's no absolute way to do this. It doesn't really matter. You can do it however you like. And, you know, it's just as long as you get something that pleases you. Let's just do that one, minus 0.125. Set it up there, same here. And there we go. Yeah, I mean, you know, something along these lines is going to be perfectly adequate, because we want just a little bit of, not exactly randomness, but irregularity. Perhaps that's the word I'm using to describe this. I think that's probably a good word. You know, because it would just be boring if we made it uniform. It just wouldn't be interesting to look at. But yeah, something like that I think will work for us, and that will allow us to move our left part up and down the spline in, as I say, a quite irregular sort of way. So that's fine. That's our first spline set up and ready to go. We can now think about what we're going to be doing with the spline in our range mapper at the bottom. Now let's see where we are here. We also need to set this one up correctly. So let's think about what we're going to need to do with this one. Once again, we want 0 to 1000 in here. And this time we're actually working with degrees. So we need to set our output range to degrees. We've got 0 to 360, and that's exactly what we want, because we want to be able to rotate this arc through 360 degrees so that we can make the left piece move in any direction. So that's what we're setting up here. We can start with our 2 points, and our left one can be 0 in the X and the Y, and our point on the right 1 in the X and 0 in the Y. So that's perfectly good. And with this one, we're creating something that perhaps resembles a mountain. That's what I did when I was making my original scene. So we'll do the same sort of thing here. We'll just bring this up to the top and just set that up. And with this one, I'm not going to be too particular about the tangents. You know, as long as they kind of work, that's perfectly good. So I think something like that will be okay. You know, again, it's not an exact science. You can set this up however you like, but that's what I've chosen to do. Okay, so our range mappers are now set up, and we can plumb these two into our position and rotation B ports, as you see there. So that's our range mappers, or rather our Expresso expression, complete. That's as much as we need to do. We don't need a huge amount of Expresso for this. Okay, so we can now move our left part of our universal joint around. We can play around with that. Now at the moment you can see that it's not playing as it should, and that may or may not be because the dynamics need to be baked. But before we look at that, we need to use some keyframe animation to make the left part rotate, and that's going to be our next port of call. We'll select our left part, and in our coordinates we want to work with our rotation B, so we'll put a keyframe at frame 0, skip through to the end and make this 7200 degrees and record there. So that should make our parts rotate, and does. Let's just play through and we'll see what happens, see if anything goes out of kilter. Okay. Yeah, I mean, so far it's all playing quite nicely together, isn't it? Yeah, it doesn't look as if anything's off. It looks pretty much as if everything is synchronized. So yeah, that's looking really quite nice. It's working very, very well. And if we go back to the beginning, everything is still synchronized. So on this occasion, the Expresso and the dynamics are actually playing quite well together. Now you can, if you wish, select this and bake everything. You can do that, that's fine. But there may not be any need to do that, and that's looking good. One thing you do need to check though, in the range mapper here, if you've got this slightly rotated, it only needs to be a tiny amount, that will cause a glitch in this. Okay, once you get to one end of the spline, it will jump instantly to the other end if you've got anything resembling this. So make sure that you zero this out so that that's totally level, and then that's fine. It's only if you've got your point at literally at 1 on the y-axis. If it's slightly below it, it won't matter so much, but if you've got it at 1, then you must make sure that these two are 0, otherwise you will get a glitch, so be aware of that. That was just worth pointing out. But yeah, I mean, everything here seems to be working quite nicely. What we can do is hold down the Option key, hit G, group everything into a null, call this universal joint, and then we can move the joint around, and we should be able to do that without any problems. And we can. It still works perfectly fine. So yeah, it's all looking really, really nice and doing exactly what we needed to do. And in times past, I have actually tried to create a universal joint using Expresso, but I couldn't quite get it to work. But using these dynamic connectors, that's a really brilliant way of doing it. And the Cardan, this is what it's really designed for. It's designed for making these types of joints. So it demonstrates perfectly how they work, and they really do their job very, very well. But yep, it's all working beautifully and looking really, really great. So that is how you go about creating a universal joint using a combination of dynamics, dynamic connectors, Expresso, and an align to spline tag, and of course a little bit of keyframe animation. Now, the one thing that you cannot do, and this is worth talking about, you can't use a motor to drive this. I did try it because I thought it would look quite nice if we could do that, or be quite nice if we could do that. But unfortunately, if you connect a motor to this left part and try and drive this, nothing will happen. Because I think the way the motor is designed to work, it's designed to work with objects that are not connected to anything else. If there's a physical connection, if you've got a connector that physically connects two or more pieces together, the motor won't work. It will only drive objects that are not physically connected. So, you've got to be aware of that. I mean, if you do a cogwheel setup, you can drive the first cog and the second cog will just be on a hinge, and it's not physically connected to the first cog, and that's why the motor can drive that cog and the other cog will be driven. So be aware of that. It's a bit of a disappointing thing that it can't do that, because I mean, ideally you should be able to connect a motor to this and it should pass the rotation of this through the chain, but unfortunately it can't at this moment in time, and that's something again that I'd like Maxon to address at some point in the future. But time will tell as to whether they actually will do. But a bit of a disappointing thing that it can't work at the moment, but that's the way it is. Okay, so that just about brings us to the end of this tutorial. So as always, I really hope you've enjoyed doing this one and that it's given you some ideas for things that you may be able to incorporate in your own projects. And if you have enjoyed the video, then please give it a like. And if you haven't already, please subscribe to the channel, leave a comment, and of course, ring the bell. And wherever you happen to be on social media, please do share this video, because all this good stuff really does help keep the channel moving in the right direction. But anyway, that about brings the curtain down on this one. So I'll see you very soon on the next tutorial.